As far as we can tell, there is no edge to the universe. Space spreads out infinitely in all directions. Furthermore, galaxies fill all of the space throughout the entire infinite universe. This conclusion is reached by logically combining two observations. First, the part of the universe that we can see is uniform and flat on the cosmic scale. The uniformity of the universe means that galaxy groups are spread out more or less evenly on the cosmic scale. The flatness of the universe means that the geometry of spacetime is not curved or warped on the cosmic scale. This means that the universe does not wrap around and connect to itself like the surface of a sphere, which would lead to a finite universe. The flatness of the universe is actually a result of the uniformity of the universe, since concentrated collections of mass cause spacetime to be curved. Moons, planets, stars, and galaxies are examples of concentrated collections of mass, and therefore they do indeed warp spacetime in the area around them. However, these objects are so small compared to the cosmic scale, that the spacetime warping which they cause are negligible on the cosmic scale. If you average over all of the moons, planets, stars, and galaxies in the universe in order to get a large-scale expression for the mass distribution of the universe, you find it to be constant. The second observation is that our corner of the universe is not special or different. Since the part of the universe that we can see is flat and uniform, and since our corner of the universe is not special, all parts of the universe must be flat and uniform. The only way for the universe to be flat and uniform literally everywhere is for the universe to be infinite and have no edge. This conclusion is hard for our puny human minds to comprehend, but it is the most logical conclusion given the scientific observations. If you flew a spaceship in a straight line through space forever, you would never reach a wall, a boundary, an edge, or even a region of the universe without galaxy groups. But how can the universe have no edge if it was created in the Big Bang? If the universe started as finite in size, shouldn't it still be finite? The answer is that the universe did not start out as finite in size. The Big Bang was not like a bomb on a table exploding and expanding to fill a room with debris. The Big Bang did not happen at one point in the universe. It happened everywhere in the universe at once. For this reason, the remnant of the Big Bang, the cosmic microwave background radiation, exists everywhere in space. Even today, we can look at any corner of the universe and see the cosmic microwave background radiation. The explosive expansion of the universe was not the case of a physical object expanding into space. Rather, it was a case of space itself expanding. The universe started out as an infinitely large object and has grown into an even larger infinitely large object. While it is difficult for humans to understand infinity, it is a perfectly valid mathematical and scientific concept. Indeed, it is a perfectly reasonable concept in science for an entity with infinite size to increase in size. Note that humans can only see part of the entire universe. We call this part the observable universe. Since light travels at a finite speed, it takes a certain amount of time for light to travel a specific distance. Many points in the universe are simply so far away that light from these points has not had enough time yet since the beginning of the universe to reach Earth. And since light travels at the very fastest speed possible, this means that no type of information or signal has had time to reach the Earth from these faraway points. Such locations are currently fundamentally outside our sphere of observation, i.e., outside of our observable universe. Every location in the universe has its own sphere of observation beyond which it cannot see. Since our observable universe is not infinite, it has an edge. This is not to say that there is a wall of energy or a giant chasm at the edge of our observable universe. The edge simply marks the dividing line between locations that Earthlings can currently see and locations that we currently cannot. And although our observable universe has an edge, the universe as a whole is infinite and has no edge. As time marches on, more and more points in space have had time for their light to reach us. Therefore, our observable universe is constantly increasing in size. You may think therefore that after an eternity of time, the entire universe will be observable to humans. There is, however, a complication that prevents this. The universe itself is still expanding. Although the current expansion of the universe is not as rapid as during the Big Bang, it is just as real and important. As a result of the expansion of the universe, all galaxy groups are getting continually farther away from each other. Many galaxies are so far away from the Earth that the expansion of the universe causes them to recede from the Earth at a speed faster than light. While special relativity prevents two local objects from ever traveling faster than the speed of light relative to each other, it does not prevent two distant objects from traveling away from each other faster than the speed of light as a result of the expansion of the universe. Since these distant galaxies are receding away from Earth at a speed faster than light, the light from these galaxies will never reach us, no matter how long we wait. Therefore, these galaxies will always be outside of our observable universe. Another way of saying this is that although the size of the observable universe is increasing, the size of the actual universe is also increasing. The edge of the observable universe cannot keep up with the expansion of the universe, so that many galaxies are eternally beyond our observation. Despite this limitation on observational abilities, the universe itself still has no edge.